In today's class, we are going to look at parallel circuits. What is parallel circuit? It is an electric circuit with more than one path for the current to flow. A typical example of a parallel circuit is as shown in figure 1. This is a circuit that shows a parallel connection of resistance. Here we have the EMF. We have it as 9 volts, and we have the positive terminal through which current enters through the circuit. We have a node at point 2, we have a node at point 3, also point 4, point 5, point 6, point 7. These are the nodes. And these resistances are connected to two common points. Like resistance 1, which is 10 kilo ohms, is connected to two common points, which are 2 and 7. And these are called the nodes. Number 2 and number 7, they are the nodes of what? R1, which is 10 kilo ohms. Also applicable to 3 and 6, they are the nodes. 4, 5 are also the nodes where this resistance 3 is being connected. Now, there are some key things you need to know about parallel circuits. In parallel circuit, the first thing you need to note is that the current that are flowing in through resistance 1, which is the 10 kilo ohms, is different from the current flowing through resistance 2, which is 2 kilo ohms. It is also different from the current flowing through resistance 3, which is 1 kilo ohms. The current flowing in the circuit is different when you are talking about parallel circuit. Let's also look at the voltage drop. In such a parallel circuit connection, the voltage drop is the same. And also, there is something you need to note. Here, E, which is the EMF is the same thing as the voltage drop. Here we have the EMF or the voltage as what? As 9 volts. That is to say that here, when you want to measure the voltage drop across this R1, here, as usual, you put your voltmeter, which is an instrument used in measuring the voltage. Here, you will see that the voltage drop here, V1, will be equals to 9 volts. Also, when you want to measure the voltage drop here across this R2, when you also want to measure the voltage drop here, which is the V2, it is also going to be equals to 9 volts. Also applicable when you want to measure the voltage drop here across R3, the voltage drop here also, which is the V3, is also going to be 9 volts. That is to say that the voltage across or the voltage in this circuit remains the same in a parallel connection. The voltage drop is equals to the EMF, which is the same throughout the circuit. That is another point you need to note. Now, when you want to calculate the resistance, the total resistance of the circuit, the total resistance of the circuit will now be just like you can see here. This is the total resistance. When you want to calculate the total resistance of the circuit, it's not going to be 1 over R equivalence or R total or R effective, which is equals to 1 over R1, which is the resistance 1, plus 1 over R2, which is the resistance 2, plus 1 over R3, which is the resistance 3. That is to say that for you to get the total resistance in this circuit, it has to be the summation of the individual resistances in the circuit. Also, when you want to calculate the total current in this circuit, it also has to be the summation of the individual current in the circuit, because you know that the current is different when you are talking about parallel circuit. The current is different. So when you want to now get the total current, is not going to be the summation of the individual currents across each resistance. Okay, let's go ahead. Now, this figure 2 also shows example of parallel connection of what? Circuit. Now here, we have the first one here. The first one, we have it as the switch. This is the switch. Then we have this as the cell, which is the battery. Then we have this as the bulb, or you can call it load. You can call it load. So this is another example of parallel connection of what? Circuit. Now, there is one interesting thing you need to note here. Remember that when you cut off this, for instance, let's assume that you cut off this. Okay, let's label this 1 and this is 2. So when you cut off all these 2, when you cut it off, you will see that this bulb 1 will also be on. It will also light up because it is connected in parallel. Then even when you try to cut off 2, even when you try to cut off 1, for this one here, this is when you cut off 1, if you cut this one off, if you cut it off, you will see that 2 will also be on because it is connected in parallel. And that is one good thing about parallel connection of what? Circuit. Even in your homes, your electricity is being connected in a parallel manner. The light you are using in your house, that is why the bulb in your room, if it gets burnt, the one in your daddy's room or the one in the kitchen will also be on because it is connected in parallel. That is one good thing about parallel connection of circuit. Remember, just like I said before, that in parallel, the current flowing is different. The current flowing is different. And also, the amount of current flowing depends on the resistance you have. It depends on the resistance in the circuit. The amount of current flowing in the circuit depends on the resistance in the circuit. Is the resistance high? Is the resistance low? It depends. It will affect the amount of current flowing. Now, let me further buttress the point by using this example. Now, look at in this example here. This is a water system. Then a water system may be compared to a parallel electric circuit. Then how do we compare this? How do we compare this? Now, the total amount of water flowing through R1 here, the total amount of water here, now this is a pump, this is a water system, so and this is the pump. Now water is flowing through this way. Now the total amount of water flowing through R1, this R1, this is R2, and this is R3, equals the amount flowing through A and also what? B. That is to say, for instance, if you have, for instance here, if this A, the amount of water coming from this, if it is, for instance, if it is 5 liters, if it is 5 liters of water, if it's 5 liters of water that is flowing through this A here, so when it enters, it's going to be distributed through R2, through R3, and through R1. So when you now add up R1, R2, and R3, you get back this 5 liters. And it is also this 5 liter that is also going to flow out from B. Do you understand that now? So if you have, for instance, now a water flowing through A, and let's assume that the number of the liter of water flowing through this A is 5 liters of water, then it's going to be distributed through RO2, RO3, and RO1. And at the end of the day, the total amount of water flowing out through B will also be RO5. That is to say, you are going to sum up RO1, RO2, RO3. It's going to give you a total number of what? 5 liters. Now, what you have to understand also is the larger pipe have less opposition to the flow of water. The larger pipes have less opposition to the flow of water than the smaller pipe. Is that understood now? The larger pipe have, like here now, look at this RO1. RO1 is larger than RO2, and RO2 is larger than RO3. That is to say that water is going to flow freely through RO1 than it is flowing through RO2 and than it is flowing through RO3. Do you understand that now? So this is a typical illustration of what? Parallel system of what? Connection of what? Electric circuit. The amount of water here passing through RO1 is going to be bigger. That is to say, for instance, now let us distribute it. Since it is 5 liters of water that is entering here, that is to say that here may have 1 liter, here may have 2 liters, then here will now have let's say for instance, here we now have okay, let's say for instance, okay, let's take it this way. Okay, here we now have 1.5. This RO2 will now have 1.5 liters of water. Then why this? We now have 2.5 what liter of water, because RO1 is bigger, is wider than RO2, and RO2 is wider than RO3. So when you now add up RO3 1, RO2 1.5, and RO1 2.5, it's going to give you a total liter of what? 5 liters of water. Is that understood now? That is a point you need to note. All right, let's look at example. Find the equivalent resistance of the circuit shown below. What are we supposed to do? Here, the first thing is we are going to write out the parameters. Then the first one is R1, which is 7 ohms. Then R2 is equals to 9 ohms. Then R3 is equals to 12 ohms. Now, for you to find the equivalent resistance of the circuit, we are going to use the formula 1 over R is equals to 1 over R1 plus 1 over R2 plus 1 over R3. So here, where our R is the total or the equivalent resistance, is the equivalent resistance, and R1 is not resistance of R1, resistance of R1. R2 is equals to resistance of R2. R3 is equals to resistance of R3. Now, let's now go ahead and put in our value. Then 1 over R is now equals to 1 over, the value for R1 is 7. Then plus 1 over the value for R2 is 9. Plus 1 over the value of R3 is 12. Then 1 over R is now equals to, then 1 over 7. 1 over 7 will give you 0.14 approximately. 0.14 plus 1 over 9 will give you 0.1. 0.11 plus 1 over 12 will give you 0.08. 0.08. So let's add up. 0.14 plus 0.11 plus 0.08 will give you 0.33. So here we have that 1 over R is equals to 0.33. Therefore, our R will now be equals to 1 over 0.33, which is now going to be equals to, will give you 3 ohms, which will give you 3.0 ohms. Okay, which will give you 3.0 ohms. So this becomes the answer, the effective or the equivalent or the total resistance in the circuit. Okay, let's go ahead and look at example number 2. Okay, here it says find the total current. Find the total current in the circuit shown below. Find the total current in the circuit shown below. Now, the first step, as you know, is we are going to write out the parameters. So the first parameter there is R1, which is equals to 23 ohms. Then let's take our R2 is equals to 14 ohms. Then our R3 is equals to 5 ohms. Then another parameter we have there is the EMF or the voltage, which is equals to 90 volts. Now, the question says we should calculate the total current in the circuit. Now, remember from Ohm's law that E is equals to IR. So we have our I, which is the current we are asked to calculate, will now be equals to E over R. So this is the formula that we are going to be using. But before we use this formula, let us find the equivalent resistance. Now here, the equivalent resistance we know, 1 over R is equals to 1 over R1 plus 1 over R2 plus 1 over R3. Then 1 over R is now equals to 1 over the value for R1 will give is what? Is 23. Plus 1 over the value for R2 is 14. Plus 1 over R3, the value for R3 is 5. So 1 over R is equals to, so let's get the value. 1 divided by 23 will give us 0.04. We have 0.04 plus 1 divided by 14 is going to give us 0.07. 0.07. Then plus 1 over 5 is going to give us 0.2. 0.2. So let's add up. 0.2 plus 0.07 plus 0.04 is going to give us 0.31. So we have it that 1 over R is equals to 0.31. Then for us to get our R, we take inverse of 0.31. Our R is now equals to 0.31 inverse of 0.31, which will give us 3.2, which will give us 3.2 ohms, which is going to give us 3.2 ohms. Then, since we have gotten the effective or the total resistance in the circuit, then let's now go ahead and use this our formula. So here is now going to be the current here is equals to the EMF is 90. The value for the EMF is 90, then divided by the total resistance in the circuit, which is 3.2. So current is now equals to 90 divided by 3.2 will give us 28 ohm, 28 ampere. It's going to give us 28 ampere. That is the total current in the circuits. I hope it's well understood. All right. So let's go over to the next. Let's go over to the next question. All right. So here it says, what is the current through R1 in the circuit below? What is the current through R2 in the circuit below? Here, let's write out the parameter. We have our R1 is equals to 23 ohms. Our R2 is equals to 14 ohms. Our R3 is equals to 5 ohms. Then the EMF, which is the same thing as the voltage, is equals to 90 volts. So it's asking us for the current through R2. Now remember from Ohm's law that V is equals to IR, which is also the same thing as E is equals to IR, because the voltage is the same thing as the EMF of the circuit. Here now is not going to be E is equals to I2, R2. It's asking you for the current flowing through R2. So here is not going to be making current flowing through R2 the subject formula. We will now have it as the EMF divided by R2. So the value for the EMF is 90 and the resistance too is 14 ohms. So we now have 90 divided by 14 will give us 6.4 ampere. Will give us 6.4 ampere. So that is the current flowing through resistance 2 will now be 6.43 ampere. All right, so let's go ahead. Find the equivalent resistance and the value of R3 in the circuit shown below. The first thing we have to do is to write out the parameter. R1 is equals to 38 ohms. R2 is equals to 49 ohms. R3, we don't know the value. We have to find the value. Then we have the current flowing through the circuit is 7 ampere. And we have the EMF of the circuit is 115 volts. So we are asked to calculate the equivalent resistance the equivalent resistance. Now, what do we do? Remember that from Ohm's law, we have it that E is equals to IR. Then, let's look at this. Then our I is equals to E over R. Then our R is now equals to E over I. Then what is the value for E? 115. Then divided by the current, 7, which will give you 16.4 ohms. So since we have gotten the equivalent resistance, which is 16.4 ohms. Now, let us now go ahead and calculate the value for R3. Now, remember that we have it that 1 over equivalent resistance is equals to 1 over R1 plus 1 over R2 plus 1 over R3. Remember that it is this R3 that we are looking for. So let's make R3 the subject formula. So 1 over R3 will now be equals to 1 over equivalent resistance R minus 1 over R2 minus 1 over R1, because this R1 and R2 crossing over equality sign, they will not be negative. All right, so let's go ahead and put the values. Okay, here 1 over R3 will now be equals to 1 over R. The value for R is 16.4. Then minus 1 over the value for R2 is 49. The value for R2 is 49. Then minus the value of R1, 1 over R1 is 38. Is 38. All right, so let's go ahead here. Okay, so here 1 over R3 will now be equals to 1 divided by 16.4. We have it at 0.061. We have it at 0.061. Then plus 1 divided by 49. We have it as 0.02. We have it as 0.02. Then plus 1 divided by 38. We have it as 0.03. 0.03. So when you add up, we have 1 over R3 will now be equals to 0.061 plus 0.02 plus 0.03. We have it as 0.11. 0.111. Therefore, our R3 will now be inverse of 0.111. 1 over 0.111. So we have the value as 9. We have the value as 9. Therefore, R3 will be equals to 9 ohms. equals to 9 ohms. Okay, now having said that, I think I'm going to allow you to solve this remaining question here. What is the equivalent resistance in the circuit shown below? What is the total current in the circuit? So please do this little exercise and drop the answer in the comment section. And don't forget to like this video, subscribe to the channel, and also share this video with your friends. Thank you so much and see you in the next class.